Bismillahirrahmanirrahim. Assalamu alaikum students. I again welcome you for the subject of operations management. We are progressing with our sixth lecture for this subject of operations management. Okay students, you must remember when we started this lecture, I told you that this subject is the blend and the combination of the different qualitative and quantitative techniques, and now we are moving towards that quantitative techniques, and in the forthcoming lectures we will discuss that what are these quantitative techniques about. And we also discussed when we were discussing the definition of operations management that it is very important for the operations managers that they should take some decisions on the basis of some facts and figures, on the basis of some mathematical and statistical calculations, so that their decision can be the more strong decision and more precisely the more scientific decision. So we will gradually and slowly progress towards those mathematical techniques, quantitative techniques, and diagrammatic techniques. We have already discussed some of the statistical techniques in the last lecture. Okay, let's have a brief recap of what we discussed in the last lecture. In the last lecture, we discussed a very important topic again, that is the TQM, total quality management. And we discussed that what is total and what is quality is about. Total means that quality is the responsibility of all the entities and stakeholders of the organization, and we will have to conduct our management activities in such a way that we should continuously and regularly satisfy our customers. So that is the concept of TQM. We also discussed that it is the not the name of short-term focus, it is actually the name of long-term focus and continuous focus. So these are very important concepts behind that TQM philosophy. Then we discussed about the contribution of Deming, who is a quality guru, and we discussed 14 points given by Deming, and we discussed that constancy of purpose is so important in quality delivery to our customers that we should always be regular, constant, and precisely define our customer requirements, and accordingly we should focus on production of our goods and services in order to satisfy the demands of our customers. Then we also discussed the characteristics of a quality environment in the organization, that it is very important for the top management to have a creation of such an environment in the organization that quality is being maintained and being regulated by all the stakeholders of the organization, and most importantly the most important resource, that is the human resource of the organization. So we discussed these 14 points in detail. Then we discussed some philosophies about total quality management. We discussed about the continuous improvement, and when we talk about the continuous improvement, there are some terminologies which come in our mind. One is the Kaizen, which is given by the Japanese, and which is again related to the continuous improvement. And sometimes we talk about zero defects. Again, what is meant by the zero effects? It is again related to the continuous improvement. Again, a long-term focus, a continuous focus in finding out the gap through which we can have the idea that how we can improve our operations and how we can improve our products and services. So that is a continuous process to find out the improvement and to take the corrective action in order to get that improvement. So this is a very important philosophy behind the total quality management. Then we also discussed a very important concept, that is the Six Sigma, and we discussed that sigma is actually the standard deviation related to the statistical concept, and how that statistical concept is being used by these quality gurus, that if we are able to have defined our two limits for quality on either side of the limit of that normal distribution, then we may be able to reduce our defects up to the extent of 3 defective products out of 1 million products. So that is the concept behind Six Sigma concept. And again, how it will be possible? It will not be possible in isolation with the different activities. It will be only possible by the commitment of the top management, and again participation of the employees towards the predetermined objectives of the organization. So important is the Six Sigma, and of course the organization should create the environment, should provide the proper training, and should arrange some workshops in order to guide their employees that how they can achieve this degree of quality in their organization. Then comes the employee empowerment. That is again a very important philosophy. We discussed some important approaches in management. One is the authoritarian style of management, the other one is the participative style of management. Now in today's modern organization and good organizations, the top management and all the managers are always interested to create a sort of participative environment within the organization, in which all the employees are being encouraged to give their own ideas, and in order to get the pre-established objectives of the organization. So again, that employee empowerment is so important, and we should give the authority for the decision making to our employees, so that they can take some important decisions within their domain, and ultimately it will help to have a sort of motivational aspect in the employees, which can again be very useful in creating and improving the productivity for the organization. Then next we discussed about benchmarking, that whenever we want to evaluate our performance and we want to progress in future, we should have a sort of standard before us. This standard can be taken from some industry, this standard can be taken from some relative and good organization, and this standard can be taken from your own organization based on some best past performance. So if we have a sort of a standard before us, then it will help us that how we can achieve and how we can exceed that sort of standard. So this is the concept of benchmarking. Again, this is a very important concept in quality management as well as in general management, because this sort of benchmarking itself is a sort of motivation for all the employees within the organization, and they always put their full efforts in order to achieve a pre-established benchmark. Then we also discussed just in time, another very important philosophy related to quality management. Just in time, that the organization should focus that what to produce and when to produce, and most importantly they should produce when the demand is there and when it is needed to produce. There should not be the pile of inventories within the organization, because this pile of inventory can contribute and can increase the cost of managing the inventory. So this is the concept behind JIT, that we try to reduce the inventories, we try to timely produce as per demand of our customers, so that we can reduce the cost of quality, and again that helps us to improve the quality, as well as it will help us to achieve the required level of productivity and profitability for our organization. Then again, class, we discussed Taguchi concepts are very important, again the concept, and when we were discussing about the quality functions, then we discussed that variation is not so good for quality management, and we always try to reduce the variation. So this reduction in the variation of the operations and the production of products and goods is being addressed by this Taguchi concepts, that how we can apply the different sort of techniques to reduce that variation in our operations. So that is again a very important concept. Again, in this Taguchi concepts we discussed some robustness techniques, and we discussed that whenever we are moving away from the customer requirements and customer demands and satisfaction, then actually we are going to incur more and more cost. And whenever we are close to the customer requirements and we are able to satisfy or exceed the satisfaction of our customers, then the management will be there, and the management of the quality will be there actually, and we will be able to have a sort of quality environment within the organization. So it is very important to have the sort of production of the goods and services that should be in between the required limits. Whenever we will go beyond that limits, that will not be good, and that will increase the cost of quality. So we should have the knowledge of all these TQM concepts, and accordingly we should also know that in the practical scenario that how we should apply these concepts, and what is the situation in which these aspects can be more beneficial for the operations managers. Okay, we also discussed in the last class about some very important TQM tools, that is the check sheets. What is the check sheets? That we make a sort of table, we have a sort of variable of interest, and we find out the we compute the frequency for that variable of interest, and after we have the sort of tally bar table. On the basis of that table we can take some very important decision. Then is the scatter diagram. In the scatter diagram, again we discussed that there are two variables, one is on the x-axis, the other one is on the y-axis, and we just collect the data and plot that data, which is again relevant to those variables of interest, in the form of a graph. And by seeing that trend of graph, we can have the idea that what should be the most relevant decision in this particular scenario. Then we also discussed the cause and effect diagram. Now what is the significance of that cause and effect diagram? If suppose you have the huge data, that is basically the raw data which is being collected after a sort of survey, then on the basis of that raw data it is very difficult for the operations managers or some other managers to take some very important decision. So what happens that we can arrange that data in the form of the diagram, which may be the cause and effect diagram. In the cause and effect diagram there is a sort of effect which is actually the result of something, and there are some causes which can be shown by the use of different branches in the form of that fish diagram. So on the basis of that diagram it will be easy for the operations managers to have the complete scenario about a particular situation, and they can take always a very good decision on the basis of just a diagram, and they don't have to go through all that pile of documents. So important is that cause and effect diagram. Then comes the Pareto chart. In Pareto chart we discussed about that 80-20 rule, that 80% of the firm's problems are actually the result of causes of 20% of factors. So as an operations manager we are always interested to target those 20% of the causes, because if we are able to deal with this 20% of causes, we are actually dealing with the 80% of the problems. So that is again relevant to the efficient utilization of the resources, and this Pareto chart helps us to take this important decision. Then comes the flowcharts. Again, what is the flowchart? It is the sort of diagrammatic description of a process or operation, that what are the different processes in the operation and what are the different steps for the flow of that process right from the input to the final output. Now again, this is a sort of diagrammatic description, and after going through the different steps of that flowchart, we can identify that what are the value added activities in a particular operation and what are the non-value added activities in a particular process. So again, that diagram or that process flowchart can be very beneficial for the operations managers to take some important decisions. And we have already discussed the importance of that value addition. If we are able to eliminate the non-value added activities from our operations, then actually we would be able to maintain the quality in our operations. So these flowcharts can be very helpful for again taking some very important decisions. Then comes the histograms. Again, histogram, there is a sort of variable of interest which is usually taken on x-axis, and then on the y-axis we normally have the frequency. Now after getting the data about a particular problem and getting the frequency of that particular problem, we draw that data in the form of a bar diagram, and we can have a sort of distribution. So what histogram tells us, it can give the idea about the shape of distribution of data, that whether it is normally distributed or it is skewed on one side or it is skewed on the other side. Then it can also gives us some important information that what is the frequency of the occurrence of the particular sort of complaints or any other thing in which the operations managers are interested. So sometimes histogram is not rocket science to be made, but again this diagram can help us to take some very important decisions sometimes. Okay, we also discussed statistical process control, that how we can control our processes. Now in that statistical control process, again we define a target value, and then we define the upper limit and the lower limit, and we try to maintain and keep our processes within those defined limits. Whenever our process goes beyond these defined or pre-established limits, then again that is the point of focus for the operations managers, and they try to find out the actual cause, that why that process or operation is going beyond that limit, and accordingly they should take some corrective action. So this statistical process control can be very helpful to keep our process and operations within the prescribed limits. So class, this is what we discussed in the last class, and our today's lecture will be again the continuation of the previous TQM tools, and today we will particularly discuss about the implication of the quality tools, and we will discuss some practical scenarios and some real life problems, that how the different TQM tools we were talking about, that is again check sheets, scatter diagrams, cause and effect diagrams, Pareto charts, flowcharts, histograms, and statistical process control. All of these techniques can be contributed towards problem solving and towards the better decision making on the part of that operations managers. So today we will discuss these important problems in the problem solving perspective and decision making perspective, that how these can be helpful to solve the practical problems faced by the operations managers. Let's take an example. Suppose this is a diagram which is showing the histogram about the heights distribution of 30 people. Now suppose your marketing manager is interested to get the data about the heights of the organizational customers in order for any purpose, for any marketing purpose or for any other purpose, and suppose he is able to conduct the survey and he has the data of 30 people. Now that data is usually in the raw form, and we cannot take a particular decision, or sometimes it is difficult to take any sort of decision on the basis of that raw data. Now what should we do? That we should arrange that data in a particular classes, and then we can draw a sort of histogram by taking that variable of interest on x-axis. In this particular case our variable of interest is what? That is heights, that is on the x-axis, and the other interest is of the frequency of all of these variables. So our variable of interest in this case is heights, which is taken on x-axis, and we are interested to draw the frequencies for the different heights. We can make the different class intervals. In this case that is from 139.5 to 149.5, and this diagram shows that there are 6 people who have the height of 139.5 centimeter to 149.5 centimeter. Again the next class sizes and class interval is 149.5 to 159.5, and again the frequency for this particular class interval is 9. What is meant by that? There are the 9 people who have the heights in between the 149.5 and 159.5. So accordingly we can draw the frequencies for the different class intervals. Now suppose we want to have the idea that how many people have the heights between 159.5 and 169.5 centimeter. Now again from have a view over this graph, we can have the idea that this is the limit of 159.5 and this is the limit of 169.5. So there are 7 people. Okay, we are interested between the limits of 159.5 and 169.5. Again, there are the 7 people who are who lie within that limits, required limits. Then if you are interested to find out that how many people have the heights less than 159.5 centimeter, so again this is the limit of 159.5 centimeter, and there are the 9 peoples plus 6 peoples, that is 15 peoples who have the height less than of that 159.5 centimeter. Then again, how many people have heights more than 169.5 centimeter? Now this is the graph for the 169.5 centimeter. So the people who have the heights of more than 169.5 centimeter is 5 people plus 2 people plus 1 people, that is the 8 people who have the heights of more than 169.5 centimeter. Then again, if you are interested in some percentage of people who have the heights between 149.5 and 179.5, now what should we do? We should add the frequency in between these intervals. Then we will divide this frequency by the total sample size. In this case, that is the 30 people, and then we will multiply it by 100. Then we will be able to get the percentage of the people who have the heights between 149.5 and 179.5 centimeter. Okay, class, why we are discussing all these sort of the limits and these sort of the things in the with respect of that histogram? Because this histogram is a sort of picture and is a sort of graphs which gives you the idea that what particular decision you should make. You know that for the marketing managers and the operation managers, sometimes it is very important to have a sort of this diagram and this sort of this arranged data so that they can quickly take some important decisions regarding marketing, regarding operations, and regarding some other thing. So important is that histogram. So these are the answers of our requirements in this particular case of histogram. So class, you may have the idea that how this simple sort of, they are not again a rocket science in making this diagram, but sometimes it can be so helpful for the operation managers to take some important decisions. Okay, let's take another example of histogram. The histogram below shows the efficiency level in miles per gallons of 110 cars. Again, a car manufacturing company is interested to find out the efficiency level of their cars, and they conducted a survey in order to get this sort of data. And so now suppose they are interested in some questions like how many cars have an efficiency between 15 and 20 miles per gallon, and how many cars have an efficiency more than 20 miles per gallon. Now on the basis of again that raw data, sometimes it is very difficult to take some important decision. So what should we do? We should arrange that data, or we can arrange that data in the form of again histogram. In this case, again our variable of interest is miles per gallon, which can be taken on x-axis, and again on the y-axis is frequency, and there is a general tradition to take the frequency on the y-axis, otherwise it doesn't have any difference. Now again class, if you are interested to take some important decisions, or the car manufacturing operation manager is interested to find out that how many cars have an efficiency between 15 and 20 miles per gallon. So if we arrange the data in the again by dividing our data in the form of some intervals, and you can in this case these intervals are 5 to 10, 10 to 15, 15 to 20, and 20 to 25, 25 to 30 miles per gallon. And on the y-axis again is the frequency of this variable of interest. Now from this diagram we can have the idea that can solve the problem of that car manufacturing company, and going through this diagram we can have the idea that what is the efficiency of the cars between 15 and 20 miles per gallon. Now this is the data, 15 to 20 miles per gallon, and what is the frequency? That is the 35. It means that there are 35 cars who have been able to achieve the efficiency level of that 15 and 20 miles per gallon. Now again, how many cars have an efficiency more than 20 miles per gallon? Now this is the frequency for 20 gallon, and this is again the frequency of 25 and onward. So we are interested in the frequency of more than 20, so we'll add this 25 plus this 20, that is 45. So there are 45 cars who have the efficiency of that miles per gallon more than 25. Then what percentage of cars have an efficiency less than 20 miles per gallon? So this is the data for the efficiency level of less than 20. In this particular case, we will add these frequencies, that is 35 plus 20 plus 15. We will divide this whole sum by the total sample size, because we are interested in the percentage. So we will divide it, this sum of frequencies, with the sample size, that is 110, and then we will multiply it by 100. So we will get the percentage of the cars which have an efficiency less than 20 miles per gallon. Now again, this is the answers for these particular questions. So you see, class, that this data is so useful to take some important decisions, and the operation managers, on the basis of this particular data and histogram, should take some decisions that how they can improve the efficiency of the cars which are not within the prescribed limits. So after this sort of presentation and after this sort of exercise, it may be difficult for the operations managers to take some important decisions regarding the quality management. So important is the practical part of these so simple diagrams. Okay class, let's take another very important example, that is the Pareto chart. Now this is again a solved example for your own textbook. Let's go through this example. The Hard Rock Hotel has just collected the data from 75 complaint calls to the general manager during the month of October. So this is the data related to the complaints of the customers. And again, you must remember, when we were talking about the quality functions and we were talking about the factors which can directly affect the quality, we talked about the complaints, that if we are able to maintain or to deal with the complaints of the customers timely, efficiently and effectively, then we will be able to maintain the quality for our products and services. So important is to give the timely response to the customer complaints. So suppose some manager is interested to go through these sort of complaints, and the manager wants to prepare an analysis of the complaints. The data provided are room service 54. It means there are 54 complaints about room service on the part of their customers. Then check-in delays 12 complaints. The pool is open 4 complaints. Minibar prices related complaints, that is 3, and miscellaneous complaints other than these factors are 2. So again, this is a sort of raw data. This is just the example of a simple company which has 75 complaint cells, and you must know that the different organization have the different complaint box for their customers, so that they can have the complaints from their customers and they can take the particular decision in order to deal with these complaints. But when we go through the data of that complaints, then sometimes again we may not be able to take some important decision, because that complaints or that data is generally in the raw form. So what we can do in this particular case, we can use that Pareto chart analysis technique in order to take some important decision. Now there are some steps involved in analyzing this sort of situation, and to draw that Pareto chart, the first step is we should have the frequencies which are already given in this particular case. The second step is we should arrange the frequency in the descending order. That is, the complaints with the highest frequency should become first, then the complaints with less frequency should come next, and so on. So we should arrange the frequency in the descending order. Then the next step is we should calculate the cumulative frequency, that we will going on adding the different frequencies that were previously arranged in the descending order. And then what's happened, that we will draw a bar diagram first for the frequency which was arranged in descending order, and then we will have the sort of line diagram for the cumulative frequency. So let's see how it happens. Now this is the table. Now what happens in this table, okay, these are the in this column, these are the different complaint descriptions, which of course can be got through some survey in this particular exercise. Now this is the frequency of this particular complaints. Now what should we do? We should arrange this frequency in the descending order. Now class, in this particular case, these frequencies are already in the descending order. Now suppose if this frequency is not in the descending order, then we will have to arrange this frequency in the descending order, and accordingly we will have to arrange this complaint description against the relevant frequency, of course. Then the next step is we will compute that cumulative frequency, that is we will add 54 to, first frequency will remain the same, that is 54, we will add 54 to 12, 66, 66 plus 4, 70, 70 plus 3, 73, 73 plus 2, 75. So we will arrange that cumulative frequency. Then if you are interested, not always necessary, we can find out the frequency of the percentage, that is the 54 divided by the total complaints, that is in this case, particular case is 75 multiplied by 100. In this case, in this way we can get the percentage of a particular complaint. It means there are 72% complaints which are related to the room service. There are 16 complaints which are related, 16% complaints which are related to check-in delays, and so forth and so on. And this is again the column for the percentage of the cumulative frequency. We will add on the these percentage frequencies one by one, and finally we get the 100%. So first of all, we will have to arrange this data in this particular form, that is first order the frequencies in the descending order, and then we will compute the cumulative frequencies, and then again we can also compute that percentages. Now what happens in the next step? First of all, we will draw a graph, that is the bar diagram, on the basis of this descending order. Let's have a view of this graph. Now again, on the x-axis is the causes and percentage of the total of the customer complaints. So customer complaints actually in this particular case is our variable of interest, which is usually taken on x-axis. Now you can see this bar that has the frequency of nearly 54. Now again we will take the complaints on the x-axis and the frequency on the y-axis. We can have some relevant scale in order to draw the data on this particular graph. Now this is the first frequency, this was the 54 in case of room service. This is the highest frequency. So first of all we will draw the bar graph for this highest frequency, that is 54. Then again we will draw the bar graph for that next highest frequency, that is 12. So this is the next bar diagram for check-in, that is the 16%. We have already calculated these percentages. Next is the bar diagram for that pool hours, then minibar and miscellaneous. So in the after arranging the data in the table, first of all we will have to draw this sort of bar charts or bar graphs. Then what's the next step? We will take into account that part of cumulative frequency. Now we'll have to draw this cumulative frequency. Now how we will draw it? This is the first frequency, that will remain the same, and this is the first point. Then what is the next cumulative frequency? That is 66. Now we will draw that 66 on that line on that graph, and we will connect this point with this point. Now this is the 66 point, that is the second cumulative frequency point. Then again we will go on adding next frequency, that is 54 plus 12, that is 66 plus 4, that is 70. So this is the point of 70. We will have a dot, and we will again connect these points. In the same way, for the cumulative frequency we will have a sort of this connection. So this is what about the Pareto chart. We have drawn the Pareto chart. Now how it helps us to take very important decision. Actually this paragraph, actually this graph tells us about that 80-20% rule. that you can see that if you are able to deal with these two complaints on the part of our customers, then actually we will be able to deal with the 66% of the complaints. And if we add on the next complaint, we will be able to deal with the 70% complaints for our customers. So when you see this line, you will see that there is a peak in this line, and after a particular point it will become constant. Now this point is important. Up to this point, the complaints are so important for the operation managers to deal with, because these are creating the major problems. That is, the 70% problems are due to these three factors. So that's what I was talking about. That is the matter of efficient and effective utilization of your resources, because organization have the limited resources. By the effective and efficient utilization of the resources, if they are able to deal with only these three sort of complaints from their customers, they will actually be able to remove 70% of the complaints. 70% of the problems may be resolved. So it is not always necessary and sometimes feasible for the operations managers to focus on all the complaints. We will have to identify that what are the most important complaints, and how we can remove the particular causes which can be helpful for the solution of the most of the complaints on the part of the customers. So this is the importance, and this is the practical implication of that Pareto chart. Students, I hope you must be aware of this sort of chart, and of course you'll have to take some practice about the similar problems in order to have the expertise that how we can take the better decisions on the basis of these sort of graphs. Now let's talk about the flow chart. Again, a very important diagram which shows the flow of the different activities from the input to the output. Now again, if the operation manager is interested to analyze and examine a particular process or particular operation, there is a lot of raw data is available. There are a lot of techniques which can be there in that particular process, and sometimes on the basis of this raw data and this sort of data may not be helpful to take some important decisions. So what should the operations managers do? They should arrange the data in the form of the diagrams, and we usually say this diagram as the flow chart, as the name shows that it shows the flow of the activities right from the input to the output. Now in this particular case, again this is the example from your textbook. This is the flow chart related to MRI exercise in some hospital, that is the magnetic resonance imaging scan. So there should be a process for conducting that sort of scan. So first of all, we'll have to identify the different activities of a particular process or operation. So what is the first step in the preparation of that flow chart? That we will have to identify the input, that is from what point a particular process starts. Now in this particular case, the particular process starts from the physician schedules. Without the physician feasible schedules, we cannot start this process. So this is the start of the process, and it ends when the patient and physician discuss with each other about that particular diagnosis. So first of all, we'll have to define that what is the starting activity of a particular process or operation. Then we will have to define what is the sequence of the other activities in between that starting activity and the ending activity. So suppose we have the list of these activities. In this particular case, there are the 11. These are the 11 activities. That is physician schedules, patient taken to MRI where that scanning facility is available. Then patient signs in. Now again, class, this is very important. We'll have to write down each and particular step. Now even if we are letting our patient to sign on a document, we'll have to incorporate that particular step in when we are going to draw that process flow chart. So it is very important to draw and to describe each and every step, whether it is the small step or the some other step, important step or not important activity, we'll have to draw it. Why it's important? Because after have the proper description of each and every step of that process, actually what the operations manager wants to do, he will have to identify the particular activities that which are the most valuable activities and which are the least valuable activities. So ultimately, after the this exercise, they should be able to eliminate those non-value added activities out of their operations and out of their processes. So it is very important to draw each and every step of a particular process. So again, these are the 11 steps in this particular process, and we can use some standard symbols in order to draw and number these sort of steps. So again, when the operations manager will have a sort of diagram before them in this form of flowchart, they can easily identify that what are the non-value added activities, what are the extra activities which can be avoided, what are the redundant activities, and what are the most valuable activities to which they should give the proper attention. So that is the purpose of that flowchart, that it gives you the power of decision making just on the basis of a particular flowchart or the diagram. Okay, again, next class, the most important diagram, that is the cause and effect diagram. Again, we have already discussed that in the cause and effect diagram, there is an effect, that is the main variable of interest about which we are going to draw this cause and effect diagram. Then there are some causes which create that particular effect. So again, the concept is same as that of the histogram, as that of the scatter diagram, or as that of the flowcharts, that we want to have a sort of diagram through which we can take some particular decision. Now again, I would tell you that these diagrammatic decisions sometimes are so important for saving your time, and especially saving the time of the operations managers or some chief executives. If you are going to submit some report to your executives, then sometimes executives may not have enough time, and especially in today's competitive scenario, they don't have enough time to go through all the raw data, and then they will be able to discuss this data, and then finally they may or may not be able to take a particular decision. But again, if you are able to display that data in the form of diagram, like flowchart, like cause and effect diagram, like some other histogram or Pareto chart, just on the basis of that diagram, or just seeing that diagram, sometimes they can take very important decisions. So this is a matter of time saving as well in the perspective of this particular diagrammatic representations, and of course that helps us to improve the quality and managing the quality for our customers. Now class, in this particular, this is again the example from your textbook. This is the particular example which is being analyzed by a basketball coach. Now he has analyzed that what can be the different reasons through which the players will not be able to basket that ball at the required destination. So he have identified the different factors for that. So in this particular case, missed throw of that ball into the basket is our variable of interest, because coach is interested that their players should be consistent in throwing their balls in the basket consistently. So this is our variable of interest, and in this particular case we will say this is the effect. Now in this cause and effect diagram, this is also known as 4M diagram, because in this particular diagram we usually take these methods, material, machine and main power as our main causes, and then we try to identify the sub causes in the form of sub branches of these main branches. So due to this 4M, that is method, material, main, power, machine, sometimes this diagram is also known as 4M diagram. We also say this diagram Ishikawa diagram, which was actually the inventor of this sort of diagram, and we also say this diagram as fishbone diagram, because it is again in the form of the fish and in the form of the different main bones and the small bones which actually identify and show the different causes for a particular problem. So suppose the coach of that basketball team is able to identify these 4 main causes. Now what are these main causes? That is the shooting processes, machine or hoop and backboard, main power related problems, material related problems, or material of the balls, that is the basketball related problems. So these are the main causes which can result into the missing of the throws into the target. So in the next step we can identify the different sub causes which are related to this particular cause. For example, one of the sub causes is size of the ball, because size of the ball sometimes is important, because the coach thinks so that it may be important, that it may be one of the reason that your ball is not on the target. So that is the important point. Then your air pressure is important, that when there will be more air pressure, then there may be the less chances of throwing the ball in the basket. Similarly, we can identify the other sub causes of these main causes. For example, in method or the shooting process, what can be the sub causes? Now again, this is on the basis of the experience of the coach, which helps the coach to identify these particular causes. Now again, aligning problem may be there for that missing throw, or the balance of the player. If the player is not able to keep its balance while throwing the ball, then he can miss the chance. Again, rim height and the rim size is also important. So this is the example of cause and effect diagram. Now if the basketball coach have this sort of diagram before him, then it can be always be helpful to take some important decision just have looking down that diagram. So sometimes we have the scattered data in the different forms, and we try to arrange the data in the form like cause and effect diagram, and ultimately it will help the managers and other important players of the organization to take some very important decision. So this is about the cause and effect diagram. Now let's talk about statistical process control. Now again, we have already discussed that it uses some statistics and control charts to tell when to take the corrective action. Again, we define the limits, and we'll have to take the corrective action when our process or operation goes beyond that limit. It drives the process improvement. Of course, it helps us to improve our operations. There are 4 key steps. Again, we measure the process. When a change is indicated, and find the assignable causes. Whenever there is an conflict, or whenever there is the process is going beyond this certain limit, we will have to assign the particular cause, that why the process is going that assigned limits. Then we will have to eliminate or incorporate the cause for that particular problem, and then after removing the cause and after taking the particular action, we should restart our revised process in that improved form. So that is what we talk about, the statistical process control. Now this is the statistical process control. Now class, first of all, again there is a variable of interest which can be taken on x-axis, and again this is the percentage or the defined limits. Now again we can take the example of that coach target value, which can be 10%, that you should throw 10% of your basketball throws in the required target. Now this is the prescribed limits, that is 0%, that is the lower limit. Upper limit is, that is 20%. Now again the coach, or in this particular case, or the operations manager in the organizational setting or operational setting scenario, they would have to define these limits, and that may be based on the certain data or on the basis of their own experience and observation, and then we try to measure the process. Now these are the different points in the different games in this particular case, and you can see that right from the first game up to the 8th game, we are, or the players are, within those prescribed limits. But in this particular case, that is in the 9th case, they are going beyond the upper defined limit, now that is a point of alert for that manager or that coach in this particular case, that what is the particular cause for this particular deviation from the required limits. So they should have taken some particular step and corrective action, so that again we can keep that process within that prescribed limits. So that is an ongoing process of statistical process control, which defines and which helps us to keep our performance of operations within the prescribed limits. Now class, again this is a very important data about the temperature and the sale of ice cream. Now this sort of data is again sometimes important for the marketing manager as well as sometimes for the operations manager, that whenever there is a peak season for their products, they should be have more focused on their operations to have the timely delivery to that increased demand. So suppose we have this data in the another, again there are the two variables, one is the temperature, the other one is the ice cream sales. Now again, if we see just this data, we cannot take any decision. We'll have to do or we have to apply some important statistical techniques so that we can be able to take some important decision. So in this particular case, what we can do, we can take that temperature on x-axis, and we can take that sales on y-axis. We can prescribe some scale limits. Now that is the limits according to your own convenience and according to the data available. Now what we do in this particular case, we just plot the particular data on the basis of this temperature and this sales. Now let's suppose the first data is if the temperature is 14.2 degree, the ice cream sale is $215. Now again 14.2 is here. This is the 14.2 in case of temperature, and this is the 215 in case of that sale. So we will plot this particular dots. So in the same way we will plot all of these plots on this graph, and this sort of graph is known as scatter diagram. Now again, when we have this graph, this gives you some very important information. Now what's that information? Now these dots are actually showing a trend about the relationship between temperature and sales. Now if we go through this line, then we can see that whenever the temperature is going to increase, the sale is also going to increase. So actually there is a positive correlation, positive sort of relationship between both of these variables. Now this sort of information can be again helpful for marketing manager as well as for the quality manager, operation manager to take some important decisions. Now again, it is obvious to see that the warmer weather leads to more sales. So accordingly they can define their operation strategies in order to meet the exceeding and more demand when the temperature is more. Now again class, let's have a view on this particular example. The problem is management is concerned that workers create more product defects at the very beginning and the end of the work shift than at the other times of their 8-hour workday. Now construct a scatter diagram with the following data collected last week. Is management justified in its belief? Now after a proper sort of observation, or after analyzing the environment of working in a particular factory or production outlet, the manager may have the idea that there is some problem either in the earlier part of the work shift or in the later part of the work shift. Now this is just an idea, but how we can confirm this idea? That particular manager can have the can collect some important data about this particular problem. Suppose this is the data for relating to this particular problem we just discussed. These are the different hours of working. That is the first hour, that is the second hour, up to the 8th hour. These are the different days, that is Monday to Friday, and this data is about the number of defects. That is, there are 12 defects on Monday in the first hour shift of working. Again, there are 9 defects in the products on Tuesday in the first hour of working. Again, there are 9 defects on Friday on the 8th hour of working. So class, in these sort of situations, first of all, what the operation manager should do, they should analyze the problem, that what decision he wants to take. In this particular decision, he is actually interested to find out that whether there are more defects in the first hour or in the 8th hour. So in this particular case, this information about the days, that is Monday, Tuesday, is irrelevant, maybe irrelevant. We are more interested in the number of defects with respect to the working hours. So that is a very important point to be noted. Now what we will do in this particular case, we can take these hours on the x-axis, and then we can plot on all of these values by taking the number of defects, that is actually the frequency, on the y-axis, and we can have a sort of scatter diagram like that. Now this is the scatter diagram in this particular problem. This is the hour of work shift, that is the hours of working, 1 hour, 2 hour, 3 hour, up to 8th hour, and this is the frequency of the defects, that is the, we are taking here any feasible scale, you know, with the difference of 2, that is 2, 4, 6, 8, and then we are going to plot each values which are given in the form of this table. Now first value is the 12, so we will plot 12 here. This is the 12 for the first working hour. The next value is 6, that is for second working hour. Now this is second working hour, and this is the 6th value, that is we will plot here. So we will just plot all of these values with respect to the number of defects and with respect to the respective hours. Now you have noted down that we are not taking into account the days. Why? Because we are not interested to finding out that whether there are more defects or on a particular day or not. Maybe some other manager interested in that sort of data, then we can take days into account rather than the working hours. But in this particular case, we are more interested to find out the hours, at what hours there is a problem. So after drawing all these dots, you can easily find out that in the first working hour, you know, from this diagram, it is obvious that on the first working hour there are more defects. Again, on the last working hour there are more defects. In between, there is a reasonable defects with respect to that first hour and last hour. So it is obvious again from this diagram that management opinion was right, that there are the problems in in the first hour of working and second hour of working. So we have identified the cause, and next step will be what for the operation managers, they will have to take some corrective action, that why is being happening that there are some more defects in the first hour or in the last hour. So that is the time when he should take some corrective action in order to improve it. Now again class, this is another example that we have some categories of complaints or defects. We have a frequency for these particular categories. Again, what we can do, we can make a Pareto chart in this particular case. These are the different categories, these are the frequencies. Now we can convert these frequencies into the percentages. Again, we can convert these percentages into the cumulative percentages, and we can have again this sort of Pareto chart which we just have discussed. But there is a difference in this particular case. What we do not compute the cumulative frequency, but we compute the cumulative percentage. So both methods are good and can be applicable. In some cases we can calculate the cumulative frequency, and we can draw the bar diagrams or bar graphs for the cumulative frequency, but in some cases we can also draw the bar graphs for the cumulative frequency cases. So both are good. You can apply either of this method. Either you can take the cumulative frequency, or you can take the cumulative percentage frequency in order to draw that bar graphs. So in this particular case, we are taking the cumulative percentage for that bar graphs. This is the bar graph for the different descending order of the percentages. This is the bar graph for the descending order of percentages, and then by taking in account the cumulative percentage, we can have a sort of this line. And again, you can see that if we are able to deal with this sort of factors or causes, then we may be able to deal with the 80% problems. Again, that is the case of that 80-20% problem, that if we are able to deal with these three causes, we can solve the 80% problems for our customers. This is another example of that Pareto charts. Suppose you have the data for the reason for unsatisfying stay at hotel, that some hotel manager is interested that why the people are not satisfied by, with staying in that particular hotel. So he is able to collect this sort of data by conducting a sort of a survey from their customers, and this is the particular frequency. Again, this is the case of Pareto chart. We can arrange this frequency in some descending order. We can calculate the cumulative frequency, and again we will draw the bar graph for that descending order frequency, and then finally we will draw the line for that cumulative frequency. So this will again be this sort of Pareto chart. In this particular case, these are the bar diagrams and bar graphs on the basis of descending order frequency, and again this is the line on the basis of cumulative descending order frequency. And again, as we discussed in the previous cases, we can easily interpret this particular situation. This is another similar example. You can always go through this example in the same way. Then again discuss about cause and effect diagram showing why a student might not be satisfied with the cafeteria. Now they can be the different. Again, this is the case of that cause and effect diagram. We can and what is the effect in this case? That is the dissatisfaction of the student with respect to the cafeteria. Again, if we want to draw that fishbone diagram or cause and effect diagram, we'll have to identify the different main causes, and then we'll have to identify the different sub causes, and accordingly we can have a sort of diagram which can helpful for the finding out the reasons, that what are the most important reasons for which are being the causes of creating the dissatisfaction among the students. So this is again the example. Again, 4 M's: materials, methods, machinery, and manpower. We have identified these particular sub causes for this particular effect. So that is helpful for taking important decisions by that manager. Now this is again the example of fishbone chart detailing the reasons why a part might not be correctly machined. Now again, part is not correctly machined, that is your effect, that is your variable of concern. Then again we can have the different main causes and maybe the different sub causes. So only the main causes are being represented here. For example, with respect to the material, what can be the main cause? That is the defective material returned to the good parts bin. And what can be the method? That can be the engineering change not related to factory. So again, these are sort of fishbone diagram which can help us to take some very important decisions, or in order to identify the causes for a particular effect, like that part is not correctly assembled in this particular case. Now again, this is the example of flowchart for purchasing a Big Mac at the drive-through window at McDonald's. So this is the case of process flowchart. We can use the different symbols and these are the different sort of sequence-wise activity. In this particular case, we have just gone through a sort of a flowchart, so you people can easily draw that steps and that activity in the form of that diagram by using these standard symbols. And after going through that diagram, you will be able to find out what are the most valuable activities, which are the essential activities, and what are the non-value added activities which can be removed out of that process in order to improve the efficiency of operations. So you can do it as we did before. So class, let's winding up this lecture about that statistical techniques regarding the managing the quality. We have gone through the different very diagrammatic approaches, very important diagrammatic approaches, which can always be helpful for the operations manager to take some important decisions regarding dealing with the complaints of the customers, regarding the efficient utilization of the resources, and regarding taking any important decision about any particular aspect within the operations settings of the organizations. So this is the practical implication, and this is the strength of applying the facts and figures, and applying the certain statistical techniques, and applying the diagrammatic techniques in order to take the decisions. So this is what we say about the scientific management. Okay class, this is the end of our lecture regarding the managing quality. We have gone through the 3 lectures regarding quality management, and we have gone through very important approaches, and I'm hopeful that you must have understood all of these techniques, approaches, quality management tools, and most importantly how you can apply these approaches and tools in the practical scenario and in taking the scientific decisions, which is the most important concern for us in this particular subject of operations management. In the next class, inshallah, we will discuss another very important technique, that is the linear programming. Okay, thank you very much class. Stay blessed. Khuda Hafiz.